Yeah, all the students, so listen carefully. In the last class, we are already discussed about Newton's second law up to the Newton's second law. We completed the derivation of Newton's second law also. According to the Newton's second law, there is a piece S equal to ma. Otherwise, it is equal to change of rate of momentum is applied on the body is equal to force applied on the body. Got it or not? Change of rate of momentum is equal to force applied on the body. That is only we are considered. And as well as when you check it, acceleration is directly proportional to F, and acceleration is inversely proportional to M. And from that one, we'll get the derivation of our Newton's second law. Yes, F is equal to ma. We'll make it for us. Okay. And now there is one more thing. Impulse also we are discussed. Impulse is nothing but yes, the momentum of the body during a time interval. Okay. Yes, the momentum change of the body during the time interval is only called a what? Impulse. That is also we already completed. And now there is we are going with our third law of motion. Very important law. Every action contain reaction with the same magnitude but opposite in the direction. Yes, Newton's third law. Okay, clear or not, all the students? Newton's third law. Which one is called Newton's third law? Yes, according to Newton's third law, we said that yes, a force F1 is acting on the body. F2 means what? It is the first body. It is taken as second body, or a body A or a body B. FAB is equal to taken as minus FBA. Yes, every force is giving one more force on the another body. The forces are equal with one another in a magnitude but opposite in the direction. Got it or not? This is only called the Newton's third law. It is also called action is equal to reaction. Action is equal to reaction. Every action is a contain reaction. Okay, clear or not? Both are equal with one another but opposite in the direction. Okay, clear or not? Action is equal to reaction. There is no need to mention to the minus again here. Action is equal to reaction. Reaction should be opposite to the action. Okay, clear or not, all the students? Now, based on this, there is so many applications are there. We are walking. Okay, now answer. We are walking to the is from we are walking to here to the where to the to where to the rocket moving. Up to that also there is a Newton third law may applicable. Okay, clear or not? When I push this board, the board is also pushed me. Okay, clear or not? Like that, every action is a contained reaction with the same magnitude but opposite in the direction. Got it or not? The terms action and as well as the reaction, the third law meaning that a force and as well as the reforce. Okay. And next one it is the term action and the reaction in the third law is a given wrong impression. The action comes before the reaction. That is, action is the case. The reaction, the effect. There is no such case. Cause, effect, relation implied in the third law. The force A by B and the force B by A act at the same instant only. Any one of them may called action and the other may called reaction. Other students don't undergo the misconception here. First A is the given action, next B is a given reaction. Not like that here. Okay, the both are working at the same instant only. The both are working at a same instant only. There is no change in the action and reaction in the time. Okay, clear or not? At a time, the action and reactions may occur. There is no time lag between the action and the reaction. Got it or not? Here we not called exactly this is only action, this is only the reaction. One we treated action, next become another become reaction. One we are consider reaction, next become the action. That is our consideration only. There is no cause exactly. No, exactly we consider action is equal to S or minus reaction. Like that, it is action, it is a reaction. Only we are not considered. A, suppose if A is the may become action, if B is also become action sometimes. Okay, clear or not? But they are working at the same instant on the same place also. Got it or not? This is only about the action is equal to reaction. This is called Newton's third law. I hope you understood. Every force is a contain reforce. Every force is a contain reforce with the same magnitude but opposite in direction. That is only called Newton's third law. Okay, please note down. This is the Newton's third law. Next, there is example we are considered here. An object of 5 kg is far away from the surface of the earth and has an acceleration 6 meters per second square as toward the center of earth. Find the exerted by an object on earth. Okay, clear or not? Here there is a what we consider, especially second law we are considered for like these bodies. What they given? An object of 5 kg is far away from the surface of the earth and has an acceleration 6 meters per second square toward the center of earth. Find the force exerted by the object on earth. Okay, clear or not? Object on earth means what? Understood? Suppose this is a fall down. There is a what happened? There is a force not only applied towards the earth. Earth is also attracted towards the chalk piece, but the force of earth is a more than the chalk piece. That's why it is a fall towards the earth. Got it or not? What you understood? Yes, there is a what? The chalk piece is only not a giving force on earth. Earth is also giving force on chalk piece. Earth is not only giving the force on the chalk piece. Yes, the chalk piece also give the force on the earth. Means what? Every action is a contain reaction with the same magnitude but opposite in the direction. But when the imbalances, okay, now when the imbalances, the body may move, okay, which are contain more force. Okay, clear or not? This is about the concept. Here the example is given as, okay, now just simply, yes, 5 kgs are given and as well as the A is an acceleration is given 6 meters per second square. Simply F is equal to what become now? F is equal to MA. M is a what here? M is equal to taken as 5 kgs. A is equal to taken as 6 meters per second square. Then automatically F is equal to become what? 5 into 6. That is become 30 newtons. This is a Newton second law basis we are considered. Okay, got it or not? Yeah, please note down this. Now we are doing the practice sheet. Yes, go with the page number 83. So many applications are there for what Newton third law purpose. Yes, when you are push the coil in front side, yes, back side. Okay, clear or not? At that time only your bicycle is the most what? Front. Okay, like that, whatever maybe you are take it is a compulsory when you applicable the Newton third law. Okay, fourth applications all are may contain Newton third law. without a Newton's third law, force application is not possible. Okay, clear or not? Yeah. Now there is a page number 83. Yeah. Now all the students listen carefully. There is a 82 page number. First one. A man getting down, running bus falls forward because. Okay, clear or not? A man getting down, a running bus falls forward because due to the inertia of rest, road is left behind, the man reaches forward. Due to inertia of rest, road is left behind, a man reaches forward. Yes, and due to inertia of motion, upper part of the body continues being in the motion of in a forward direction, while feet comes to the rest as soon as they touch the road. Yes, he leaves the forward as a matter of habit. Yes, of the combined effect of all the three factors what are stated in A, B, and C. Yeah, all the students you know very well. Once you observe when there is a yes, it is not a good habit, but when we are jump down from the running bus. Okay, clear or not? Running bus, automatically what happened? We want to jump front side and we want to move somewhat with the somewhat time with the bus. Otherwise, we may fall down. What is the reason for it? Yes, why? Because when we are in a bus, at that time we are contain the same velocity of bus also. Means what? We are in a motion. You know very well. Yes, but we want to when we want to jump from that, we want to become stop. We don't want to go with that much of speed of bus. Got it or? It's not possible to move with that much of speed of bus. Got it or not? I hope you got it here. Yes. And here suddenly we are jumping from it and we are not moving with somewhat velocity, we fall down. Okay, because of what? We are not coming to the rest suddenly from the motion. Got it or not? We are not coming suddenly from rest to the motion. Yes, at that time what we contain? Which type of inertia? Kinetic inertia or dynamic inertia. When we are moving from the bus, yes, kinetic inertia and as well as the yes our dynamic inertia. Totally not. But when we step down on earth, our foot want to become rest, but our total remaining body may not become rest. Okay, clear or not? We touch with only the what foot only, na. That's why that may comes to the rest, but the remaining body may not comes to the rest. They are in a motion. At that time, we have inertia. What is that inertia? Kinetic inertia, dynamic inertia. That is the answer is B. Due to the inertia of motion, upper part of the body continues being the motion only in a forward direction, while feet come to that rest as soon as they touch the road. Got it or not? That's why only the man or man getting down running bus. Yes, falls forward. Forward only we falls. One second, we not forward back. Okay, in case of fall, we are make like that. Okay, now yes, that is why only what we have to do. If it is a compulsory. You want to jump from it. You want to move forward only, not go, not try to go backward. Okay, clear or not? Understood or not? We are should compulsory. It is a dangerous to our okay na journey. Understood or not? Don't try to get it is, but you have to should compulsory. You should yes after you put that your foot on it, you should move forward with somewhat distance with the bus. Okay, no problem, make it. Otherwise, suddenly you want to stay down, you should be fall down front. Okay, clear or not? Got it or not? Why? Because your body is not ready to come to the rest. Your body always contain velocity. How much contained by bus? Okay, when you are coming down from the bus. Okay, clear or not? It is also called what? Kinetic inertia. These properties are called kinetic inertia. The answer is B. And next one, a man is at rest in the middle of a pond on perfectly smooth ice. He can get himself to the shore by making use of a Newton's. Okay, a man is at rest in the middle of the pond on a perfectly smooth ice. He can get himself to the shore by making use the Newton's. Yeah, there is a what we want to apply all the three laws. Okay, clear or not? First law, second law, third law. Why? Because we want to move somewhat. Okay, now we require the first law for explain. How much amount of force? Second law. Okay, now every action is a contain the reaction. That is the third law. Every law may useful for him. That is only the answer is second purpose D. Got it or not? Next. A jet plane flies in the air because of what? Yes, there is a what? You know very well. That is the Newton third law is applicable on the jet planes. The gravity does not act on the body, moves with the high speeds. It is a wrong. Yes, the thrust of the jet compensate the force of the gravity. The flow of air around the wings cause an upward force which compensate for the force of gravity. The weight of air whose volume is equal to the volume of the plane is more than the weight of the plane. Okay, clear or not? There is the answer is second B. The thrust is nothing but one type of a force. The thrust of the jet means what? Very high forces are coming from the jet plane and they pushes that. Okay, now yes, gravity force against whatever the force is working, gravity force is working downward. Our force is working enough. Our body is want to move forward. Then how it is possible? Yeah, against the gravity force, these whatever the jet gases are giving force. The gravity force may action. Our jet forces are whatever given, it will be reaction. Yes, at that time there is a when our reaction force is greater. At that time only it will be flies. Otherwise may not flies like that. Got it or not? Remaining or not the gravity does not working on the moving bodies of with the high speeds. Every body is influenced by the our gravity. Yes, got it. Answer is B. Yes, next one, fourth point. Before taking a long jump, an athlete runs certain distance due to clear or not? Inertia of rest, inertia of motion, inertia of direction, yes, and of force. Okay, clear or not? Yes, before taking a long jump, an athlete runs certain distance due to. Okay, clear or not? Yeah, you want to take why there is the running. Directly you are not taken. Okay, na? Yes, from some particular wherever the line it will be there, from that particular line only you want to make a long jump. Any problem? Yeah, there is a may get jumping possibilities or not. Yeah, but whatever the target is may not possible. Why? Because when we want to come for that particular position, we want to stop. Okay, clear or not? Yes, when we want to jump, it is a what? Which type of a motion? Kinetic motion means what? It is under the motion. Come from rest to the motion here. Okay, clear or not? We want to continue that motion only in the air also. Okay, for this purpose only we want to move somewhat. Yes, running. After the running, we are continue that motion only. That's why which thing it is? Motion, inertia and motion. Okay, clear or not? We want to continue the running. Yes, in the air. We want to stop at that particular place. Ourselves only we stop it. Yes, ourselves only we stop it. But our body is not ready to stop. We want to move somewhat up front. That is why there is a what we are continued that motion. Yes, At that time, there is a which inertia is working? Kinetic inertia is working. In the long jump, which type of inertia is working? Yes, kinetic inertia is only working. That is the what? Inertia at motion. Yes, fourth point is the what? Inertia at motion. That is the B. Yes. Yeah, the wild stone, you know very well. The wild stone, nothing but you have to take a stone and connect it by the thread, and we make it is like this. Okay, that is called wild stone. Okay, the wild stone is working on which thing? Based on which thing it will be working? Yeah, changes of the direction, inertia of the direction. Okay, clear or not? Based on the inertia of the direction only it is a working. That is the what? C. Fifth one is the C. Okay, clear or not, all the students? What is the inertia of the direction? Everybody want to move the what in a linear direction only. But when we apply the force on it, suddenly there will be changes. Actually, everybody want to move in this direction. Okay, clear or not? Yes, suppose it is a moves in a form of a straight line. Okay, clear or not? It is a moves in a straight line only, linear motion only. But towards the center, there is any force is working. It is not a moves in this direction. It is not a moves in this direction. Meanwhile, it will be selected the yes, which direction? Circular direction. The wild stone, nothing but what? We take one stone and connect it with the wire, and it will be taken at a finger. Okay, now we'll make like this. It will be rotation. Okay, now that is what called wild stone. How it is working? Based on the changes of the inertia direction. Got it? Or yes. And next, sixth question answer. What is the sixth question? A running boy falls in the forward direction. If he is tripped by a stone because of what? Inertia of motion. Okay, now running boy contain which type of a motion? It is a contain of motion. At that time, suddenly stopped. Okay, he fall down. Why? Because inertia of motion. Okay, yes. That is the what? Answer is C. Please note down the level one. This conceptual question answers. Now we go with the level one. Yeah, so it is a B. Inertia of motion, it is a B. Yeah, next to level 1 questions. Yeah, you are on a frictionless horizontal plane. Where you are on a frictionless horizontal plane. How can you get off? No horizontal force is exerted by pushing against the surface. Yeah, it is possible by the spitting or a sneezing. Okay, clear or not? Yes, why? Because because of the spitting and sneezing, somewhat momentum may possible to generate. Okay, when the momentum is possible to generate, there is a change of rate of momentum is possible. At that time only force is exerted. Otherwise, it is not a possible. On the frictionless force without a horizontal forces. Okay, it is not a possible. Yes, that is why sneezing and as well as the skipping. It is spitting. It is only possible. That is the seventh answer is taken as sorry. First answer it is taken as B. When a particle in a motion always acted upon a force in a direction perpendicular to the direction of motion, the path followed by particle is. Okay, clear or not? When a particle in a motion always acted upon by a force in a direction perpendicular to the direction of motion, the path followed by the particle is. Yeah. Here, one second, when the particle is moving, yes, always the force the perpendicular to the direction of the motion, the path followed by a circular motion. Okay, how you know? There is we are taken a what here the particle of the body is force is applied in which direction? There is in this particular direction. Okay, always coming towards the center. The body is moving what? Like this. Okay. Yes, there is a when you draw, there is a perpendicular line. It is a perpendicular to this particular path or not? Yeah. But is our radius is always perpendicular to the circumference of the circle. Okay, clear or not at that particular point? That's why it is which path it is selected? Yes, it is selected circular path. Okay, the answer is C. Okay, clear or not? Second answer is C. And now there is an acceleration of the body is to be doubled from the initial value. Why? By what factor is acting on the force to be increased? Okay, you know very well. Force is directly proportional to acceleration or not? Yeah, it is a force is directly proportional to acceleration. Okay, clear or not? Yes, that's why here there is a what they giving F is equal to taken somewhat F1 for what A is equal to taken somewhat A1. Now F is equal to what? In case A is equal to become what? They taken a what here? Acceleration of the body is a double. Okay, means what? The A it is a taken somewhat. A1 is equal to somewhat A, A2 is equal to somewhat you take 2A. Then what happened? What happened now? There is a F by. Yes, it is the taken F1 is equal to F. Okay, now F1 by F2 is equal to what here? Actually, A1 by A2. Okay, now which implies it is also written as okay, now what it is given? F1 is equal to somewhat F it is a given by F2. What is the A1? A. It is a what? 2A. Got it or not? Yes. And now automatically, yes, A and A cancel get each other. F1 by F by F2 is equal to what happened here? 1 by 2. Then F2 is equal to taken as 2F. Got it or not? Yes, it is also become double. Okay, now acceleration is a double, and as well as the force is also become double. Yes, it's a become twice. Okay, now 2 times it will become increased. Answer is B. Okay, the third answer is what? B. Yes, fourth one. A car is a rest. We can conclude that the weight caused by the gravitational attraction to the earth and the contact. Yes, the force of the car with the earth are equal and opposite. Because what? Yes, what it is a given? A car is a rest. We can conclude that weight caused by the gravitational of attraction to the earth and the contact forces of the car with the earth are equal and opposite because okay, the two forces are yes, third law is the net force acting on the car must be zero, neither of above and all of these. Yes, why the car is a rest here? We can conclude that weight caused by the gravitational force. Which one? There is very well free body diagram. Okay, suppose you take a one car here. The car is influenced by the so many things, so many forces are working. And it is a rest because what actually there is a two mainly forces are working. Normal forces are working on this one and as well as the weight is also working. Normal forces in upward direction, weight is in a downward direction. Yes, and in case there is a frictional force is also working, and as well as there is a what one more force, yes, a forward force. It will be like this, and it will be like this. When the car is become rest, totally four forces are working. What are the conditions here considered? Yes, may fall down because what? In case the normal force and weight is imbalanced. Okay, clear or not? In case there what actually F and F is imbalanced, it will be moves. Otherwise, it will be rest. All are balanced, it will become rest. Here, what happened? The normal force and weight is yes, the forces which are followed the Newton's third law. Okay, weight is in a downward, normal force is in a upward direction. Okay, clear or not? Weight are opposed by the normal forces. Why either it is? The normal forces are equal to the weight, but opposite in the direction. The answer is become what? The two forces are third law pairs. Okay, clear or not? The net force acting on the car, yes, must be zero. Okay, now, and all of those are given that whatever the net forces on the car must be zero. Okay, clear or not? Equal and opposite also correct only. Okay, now actually the answers are become A and as well as the B. Both are correct only. The net force is acting on the car is a zero. At that time only it is a rest. And as well as these two forces, what are the two forces? Weight and as well as the normal forces are which one? They are follow the Newton's third law. Okay, the Newton's third law based on. Then answer you write A and B both. Because all of them were they given, but none of these is not correct, na? The given C is neither of the above or not. Yes, that is not a correct. Fourth one answer is A and as well as the B. Yeah. Next one, the fifth question. A gun recoil when it is a 5. the recoil is the result of action and reaction of force pairs. As the gases from gunpowder explosion expand, the gun pushes the bullet forward and the bullet pushes the gun backward. The acceleration of the recoiling gun is S greater than the acceleration of the bullet, smaller than the acceleration of the bullet, and the same size of the acceleration of the bullet, and none of these. Yes, acceleration of the bullet is moving forward, and as well as what actually there is a gun is moving backward. When the gun is fired, the gun should be compulsory get a backward force. Okay, the forces are same here. Okay, because of that only gun is moving forward. The acceleration should be also same. Bullet acceleration, gun acceleration, same only. Answer is become C. Okay, fifth answer is what? C. This is only about today's class. Tomorrow we'll go with the remaining concepts. Okay, numerical problems are there from tomorrow onwards. We'll go with the numerical problem tomorrow. Level 2 and level 3. Yes, thank you.